Alright, so next we're going to talk about water, right? Water has some really interesting properties, and they're all as a result of those hydrogen bonds that we talked about earlier, right? We have this Lewis structure for water, and within water we have those polar covalent bonds, but between water we have these hydrogen bonds, right? The slight negative and positive charges attract each other. Now, water has some really neat properties. Now, remember, pretty much, so there's a lot of different liquids that we're all really familiar with that are comprised mostly of water, right? You've heard, we talked about when we started chemistry, that most of our body is comprised of oxygen and hydrogen and carbon, and that's largely because we have a great deal of water in us, and most of us drink things that contain a great deal of water throughout the day, whether or not you drink pure water, right? And pure water has this perfect balance of oxygen and hydrogen ratios. And remember, this all relates to pH. We talked about pH in class, where we have some things that are extremely acidic, things like coffee and soda and so forth, and things like ammonia and bleach that are really basic. And these all have to do with the ratio of these hydrogens to this oxygen molecule in a solution, right? We talked about how our blood has a very sensitive pH, and we have special proteins called buffers that balance that pH. And remember, the pH scale is essentially, it's kind of counterintuitive, right? The lower the pH of something, the more acidic it is. A really good example is Tums, right? So you guys know if your stomach hurts you take Tums, and Tums essentially have calcium that bind that those extra hydrogens, right? And they essentially increase the pH of your stomach, right? Because they make it more basic, okay? They make it less acidic, all right? So lots of really good examples. pH, it essentially all relates to this water molecule. And this water molecule conveys a lot of really interesting and important characteristics to water, right? Cohesion is one of them. Cohesion, also known as surface tension. Surface tension. Really unique characteristic of water. We talked about cohesion. We essentially we talked about my grandmother, right? My granny acting crazy, right? Jumping off of cliffs in Bermuda, hitting this surface of the water. And cohesion allows water molecules to be attracted to each other, and it also creates a surface tension where if you hit it from too far up and those water molecules are not able to separate these hydrogen bonds quick enough, then essentially it's like hitting a hard surface, right? It also allows for a lot of really important characteristics. Remember, we have those water striders. So now, this cartoon, it looks like some kind of alien attacking my poor granny. But in any case, let's just pretend this is a standalone creek somewhere, right? We have these water striders, and water striders have these waxy legs that are covered in chitin, right? We talk about chitin as a polymer, right? As a polysaccharide, right? Just as an example of a polysaccharide. But in any case, this water strider's legs are covered in wax, they're hydrophobic, they're covered in chitin, right? And essentially they have the ability to spread their tiny little hairs over the surface of water and allows them to walk on the surface. We saw that animation of that lizard running along the water and get the idea. Cohesion is what attracts these water molecules to itself. Allows water to essentially also be transported up extremely tall trees, like those giant redwoods in California, right? Lots of important characteristics that are brought to light through cohesion, right? And water is also a really good solvent. Lots of things dissolve in water. And that has to do with the exact same thing, right? We have these negatively charged oxygens and these positively charged hydrogens. We talked about salt dissolving in water, right? Where we have the positive from the sodium being attracted, and then the negative from chloride being attracted to the hydrogens in the water molecule. It's a really good solvent. It allows you to dissolve a lot of things in it, which is why it's always at eye wash stations, right? Allow you to dissolve those particles out of your eyeballs when you get them in there, like I did in organic chemistry lab, right? So, water is also less dense when frozen. If you think about something like an ice cube, right? This has to do with the fact that all of these water molecules form this crystallized structure, right? This is confusing though. It's less dense. For some reason people mix this up, and I think it's because if you feel ice, it feels hard to the touch, right? But the water molecules have more distance between them because essentially they're slowed down as a result of cooling, right? And that distance creates this crystallized lattice structure, which results in the formation of ice, right? So it's less dense and frozen. Why is that important? Because of baby polar bears, right? We talked about that a great deal as well. It also has a high heat capacity, allows water temperatures to remain stable in certain areas, allows ambient temperatures to remain stable around large bodies of water. We talked about that's one of the reasons things like islands have very stable temperatures. Has a high boiling point, right? We talked about that as well, and that has to do with its high heat capacity as well. And this is because these bonds between the water molecules, hydrogen bonds easily broken, right? That's why we have these hydrogen bonds between both sides of the DNA double helix. But they also are easily formed, and because of that, when you're trying to boil water, you're trying to break these bonds, and then they readily reform over and over, right? So a good brief overview of the characteristics of water.